Continuous random variables, the fourth question, the one labelled question 7. It says here state values. They don't want you to do any calculation. They just want you to spot what it is. Okay? State the values for the median. The median is where the area so far equals a half. What are they hoping you'll spot here? Does anybody want to say?
It's 1 because your first figure is between your 2 and 1 is a half.
Yeah, that's exactly right. If you sketch this thing, it starts at 0 and it goes to 1, and that has a height of a half everywhere. So the area of that bit is a half. So the median is 1. Well, where's the lower quartile? The lower quartile is going to be here at a half. So the median for this one is 1, and the lower quartile is a half. And there's 1 mark for each of those. I remove part B because part B isn't on our syllabus. Part C, the probability between 2 and 3. If I just finish this off a minute, what happens here? What does this curve look like afterwards? What is this sort of thing over here? Okay, yeah, it's going off in a sort of quadratic direction. So we've got 4 over here. So I want the probability x lies between 2 and 3.
It's going to go down to 0 at 4.
Oh, it's going the other way, sorry. We're saying.
It doesn't
I think it's a smiley one.
Yeah, it's a smiley
but it
one.
has to start lower.
It's a smiley one, but it goes down like that.
Smiley one, but it
Slightly
goes
up.
down like
Starting
that.
with x minus 4 being
Like
3.
that?
Yeah.
Ah, right, yes.
Very
Because when we stick x as 4 in there, we get 0 out, don't we? So, yes. So, those there aren't there at all, it's just one down here. Okay, you're correct, thank you, well spotted. Between 2 and 3, we know it's on this part over here, nothing to do with the rectangle over there, so it's integrating between 2 and 3 what our function is, which is this thing here, 1 over 18, x minus 4 all squared. If you're doing that integration, I would just take the 1 over 18 out straight away. I would be tempted to multiply out the bracket. You don't have to do it. Some people would just be tempted to go to the calculator straight away and type it in to get the answer out. I still don't even consider doing that. So if you're doing the integration, add 1 to the power, divide by the power, put your limits in of 3 and 2, divide it by 1 over 18, and according to the mark scheme, you're going to answer out of 7 over 54. Which is the same as 0.130. Those of you who did it on a calculator, do you agree with that?
Yeah.
Fine, okay.
And that's only 2 more.
I've also got over here 0.1296 recurring is what they've got on the side of the mark scheme. Okay? But for that bit of the question, here we go, there are 2 marks. There's 1 method mark and 1 answer mark. So 2 marks for that. Okay? So we're on 4 marks so far for this question. Next bit of this question, show that the upper Q, the upper quartile, satisfies this equation. Okay? Right, hence evaluate Q. 3 marks for this first bit. How are we going to do this? How are we going to find where this Q is? Anybody want to start us off? Dan?
I differentiate, integrated between 4 and Q.
Okay, yeah, from Q
Q4, sorry.
up to the lower, from the upper quarter up to 4, you know that the area, so basically the integral, there, must equal,
A quarter.
yeah, if we look at the top end, there's a quarter above the upper quartile. It's worth doing it that way rather than saying 3/4 underneath, because underneath you've got 2 different curves, you've got a flat bit and the curve. So it is better doing it that way round. So if you do that, I'm going to take my 18th out there. I multiplied that out before. I have to integrate that between Q and 4. Now this one here, the people with the calculators can't do on the calculators, can they? They've actually got to do it properly. So, integrate this. X cubed over 3 minus 4x squared plus 16x between 4 and Q. I've got a quarter over here. I've got a 1/18 over here. I could take that 1/18 over here and times by 18. Everybody happy with that?
Yeah.
Stick 4 in. 4 cubed. 4, 16, that's 64, isn't it? 64 over 3, that's 4 cubed as well, isn't it? So that disappears. Have I done that correctly? And then 16 times by 4, that's 64.
Why is it over 3 the second bit?
Yeah, one of them stayed.
I made that bit up, didn't I?
Yeah,
Okay.
so
There we go. And over here, that's going to be q3 over 3 minus 4q squared plus 16q. And 18 divided by 4 is 4.5, isn't it? Okay, so minus 64 and plus 64 go. So I've got 64 over 3 minus q cubed over 3 minus minus, which makes plus 4q squared minus plus, which makes minus 16q equals 9 over 2. That's the cubic. Can I just make an assumption that you can just solve those on your calculator?
you can.
Okay, so you would need to combine the constant bits, type that into your calculator, and you'll get an answer out. So has anybody got an answer they think is correct for Q, which is the very final bit of the question? Dan?
1.619.
1.619 is correct for Q, but we've missed part of the question, haven't we?
You could
Show that it satisfies that bit over there.
if you use Pascal's triangle, I just use that.
Yeah, I've done it a different way than a lot of us.
Okay, can I have a look at that one in a minute? Okay. That's a bit for the final bit down there. Show that it satisfies up here. Let's just look at that. If you did that integral a different way without multiplying that out up here, if I wrote that integral out and I did not multiply out, I'm just taking that 1/18th out first of all, just to get these three marks up here. If I integrate this, are we all happy that you can just add 1 to the power on the brackets, divide by that 3, and divide by the derivative of the brackets? We happy with that? So you put a 1 down there, and then I've got my 4 and my q and my 1/18th and my quarter. If you bung the numbers in there, so I did this last week. If you bung the numbers in there, move stuff around, you do get the expression they want over here. That does come out. Okay, and we got the final answer bit there as well. So if I show you the mark scheme, I'm afraid you can't use exactly because they've done it a different way here, because I took out part B, which isn't on your syllabus, but there were 3 marks for D1 and 1 mark for that one. If you've got this number down here, I'm happy for you to give yourself 4 marks for that bit altogether. Okay, today, because it's near the end of term, and for once I'm being sorted nice. So we've got questions so far that were out of 12, 5 and 10, and then this one's here is out of 2, 4, this one's out of 8, isn't it? So that's 20, 35?
Yeah. Yes, that 5.
Out of 35. So let's have some grade boundaries. Okay. Right, 35 times by 0.9. 31.5, so we'll call that one 31.8. That's 28. So it looks like we're going down in 3s. That's 25. That's 22. That's 19. That's 16.
Down in 3 then 4.
There we go. Those are the grade boundaries.